Hello everyone, this is a little project. It's just a little one of them matrix displays using 4 8x8 LEDs. That's just so you can see it. Basically, all it has is this USB socket in the end, and all that does is yeah, let's see if we get a bit brighter. No, all that does in the end there is supply power, 5 volts power. There's no USB connection, data connection, so that's it, and it just sits. It's got 4 feet, and it just sits like that, and you can just stick it anywhere you want and it'll display stuff on there. Let me just move my phone. I've made a new stand for it. This time a bit lower, so I'm going to stick it on this stand and I can place this anywhere I like now, so it makes it a bit better. So let me just give me a minute. There we go. You can see it a bit closer now. I don't have to keep lifting it up. So what I've got in the box is just undo with the 4 screws. Yeah, with my hand in the way. Use the other hand, so you can see. So we I just hold in 4 screws. What I've done is I've glued everything together. Everything together. I've even glued this in place, but I've left the back so I can unscrew it and get in. And the way I fasten it is I just put a screw down through the where the two where the tab comes through and the back panel. And what happens is when you screw a screw in there, it grabs both pieces and holds it in place. So I don't know if you can see that. I'll take the back off, and then you can see the screw just goes down the side and grips it. There, can you see that? It just goes down the side and grips it still, but it doesn't split the wood. So you know, you can see it on the end there. So the screw grabs this on this side, and it's grabbing the actual the back piece as well. So you can see all I've got in here. Let's just get a bit more light. There we go. All I've got in here is the well, they call it the ESP01. It's actually an ESP8266, but the smaller version of it, you know, less pins. I've got an adapter here, so this is what I use for uploading stuff. So you can see that it has get the in focus. This shows you the pin outs. So you can see it runs on 3.3 volts. We've got a ground, and we've also got a TX and an RX pin. There's the reset and an enable, and we've got the IO2 and the IO0. Now the trouble is with this. Well, let me just take this one out so you can see underneath. In fact, you can probably see on this one as well, because I went through about 3 of them. But let me just zoom in on that. Can you see where I've broken out the chip here? That was to get to this pin 1. I soldered a wire to it, but the thing is, they never put a pad on the PCB for the pin. and just a little tiny tug on it snapped the pin off. So I tried to open it up to get back to the pin, but then I noticed there's like another one next to it here, so trying to put some solder on that end one pin, I've no idea what this bit of metal is at the corner, so I've left that basically. This one actually uses the if we look at the pin out on here, this one actually uses these two pins, and it uses the TX pin as well, so I've got 3 pins. But while I was actually doing the software, the firmware, and I wanted to diagnose this, I needed the serial pins. So the actual chips, like I said, that there is another GPIO pin on it, which is not broken out in that corner there. Let's get that in focus. Yeah, it's actually not broken out. So what I've actually got, like I say, I went through 3, and I didn't damage them. Like, I just broke off that extra pin. But you can see with this one, what I did while I was doing my programming, and I wanted to diagnose through serial. I still needed the 3 pins, so I used the two, the IO0 and the IO2, and then I've also used this pin here, which I think was IO4. But as soon as I soldered it this time, what I did was, I don't know if I can make that show up. See if I can get the lighting on it. Ah, right. Can you see that I've set everything? I've set everything in resin. I use that UV resin, and I put a big blob of UV resin over it, so this wire can't pull on that pin, and basically it holds it all in place. So now this one actually has these 2 pins, the IO1 and the IO2, and I think this is now IO4 as well, so I've got 3 pins coming out of here, and that way I was able to still use the TX and the RX pins for serial diagnostics. But once I've done it all, then we don't need that extra pin, because I can use the TX pin instead, since I'm not doing any more diagnostics. And if we look at this, you can see here that it actually needs 3 pins. So we've got the clock, cable select and data in. But now that I'm not using the UART, I can use one of the UART pins for the cable select. I'll show you that when I do show you the code for it. So I'll just stick that back in, which is this one. And I'll stick the back on it, because we don't need that in it off anymore. Yeah, put them 4 screws in. Am I still in focus here? No, I'm not. Of course not. See if I can get a bit more brightness. Yeah, how's that? That looks good. So yeah, stick that pin in there. Sorry, that screw in there. And like I say, it just sandwiches, the screw just sandwiches between the two, the tab and the thing, and it holds it on basically. It saves having to drill a hole, and it snapped the wood. We got that in shot, yeah. Whoops, I need to hold that steady. Yeah, hands in where? How's that? Right, next one. Swap hands, I think, with this one. So you can see. How's that? Oh no, I still got my hand in shot. Try that. How's that? There we go. Try the other one. Am I in shot? Yeah, I think so. Let's try and keep it all in shot. There we go. That's quite solid. That holds it all together. So yeah, so there it is all together, and you can put this anywhere in the house. Basically, what I've done with the ESP01, I'll call it ESP01, is as soon as you add power, it logs onto your local network, your Wi-Fi. Because you obviously need Wi-Fi at your house for this to work, and you also need internet connection because there's some features that it gets from the internet. And so basically, what happens when you add power? Let's see if we can get it on in shot. So I've got my USB, my mini USB here. I mean, if you're going to make one of these, you can put any USB plug on the end. You can even just put a barrel jack on the end. All you have to do is supply it with 5 volts. That's all this is doing. And basically, you can either just use a USB from your computer, or you can have a USB charger, one of those wall warts to power it, basically. But basically, all this does is put 5 volts in. So stick that in there, and as soon as you stick it in, we light up. Let's see if we can get. Oh, you can't really see that, can you? Let me see if we can get the lighting better. There, how's that? Right, hang on, I'll just unplug it and start again. So what we do is we plug it in, it'll all light up. It comes up with my first, it's just test page, that, and then we've got 192.168.0 and 166. So that is the IP address. So once it's logged on, it displays the IP address it's being given to your local network, to your Wi-Fi network. So I'll leave that like that. I wonder if I can get a bit of colour there. Let's try. Yeah, I think that's about the best, isn't it? Oh, I nearly had it there. Crap. Where did I click? Is that better? Can you see it? Let's try it on there. I think that's better, isn't it? 166 there. So I wonder if I really tilt it a bit. No, that makes it worse. So you can see the LEDs. Actually, I've got that in the shade as well. Like otherwise, you'd see. Oh no, it must be going faster. Let's try that. Oh, that looks a bit better. Yes, so you can see that now. It's like I say. So what we do is I'm just going to change things. I'm just going to make this a little bit smaller because I want to bring up a web page. Give me more. Alright, so here's the code that's on the ESP01. I'm going to call it an ESP01. Well, that's what you buy it as anyway. So they're really cheap, and like I say, this is like I like to make cheap projects. So here's the code. As I mentioned, it is actually an ESP8266. So that's the library we're going to use for it. And the way I'm going to communicate to this is through a web socket. So we need a WebSocket server. The credentials, that is where I keep all my credentials, because I don't want to make public my Wi-Fi login and password. But you can either make yourself your own credentials header file, or all you have to do is you just uncomment these 2 lines here, So if we just uncomment them 2 lines, you type your the name of your Wi-Fi you're logging with, and your password here. You change them to and leave that like that, and you just remove that by commenting that out like that, and then you upload this as it is to the ESP01. But like I say, I have this file, so I'm going to use that file, and that's that one I want. Oh shit, I don't know how frig I did there. Hang on, let me just get back to where I was. Oh right, yeah. So yes, so I'm leaving mine like this. Now if you want to attempt to do some debugging and add an extra cable, I have done this here, which what this does is changes the pins. So if you want to use the TX and the extra pin 4, yeah, it's GPIO4, which is on the corner of the chip. If you manage to solder a wire on there and keep it from breaking the pin I mentioned, you can, if you uncomment this here like that, then what it does, it makes that pin the CS pin, and it sort of, it also gives you the serial down here, and allows you to do serial debugging. But the way I've done it here, I suggest you leave it because as it is, just like that. So leave that commented, leave that like that, so it's commented out, and that enables you to use the board I've made for this to plug in. I'll come to that a bit later as well. So, but this is all that's uploaded to the ESP01. All these are just register locations. These are locations to particular registers on the Max 27219. These are the controller chips that control the 8x8 matrices, and these are just values that you stick in certain values you stick in certain registers to make it do things. What's the important thing is this buffer, this piece here. This is, I've initialized it, I've put something in there to make it show a test page basically. So what I'm going to do is I'm just going to unplug this again and plug it back in. You'll see it come up with a pattern, my test pattern. So I'll just unplug it and plug it back in. There you can see it says Tim, and it's got like an hourglass and a round ball before it shows. That is what's actually in the buffer to start with. It's just a test page to make sure and check that it's actually reading the display buffer here that I have here. Now I have this program here, so should you want to change that before you want to upload it, I have this program. Right, this program, I'll just find the web page, give me a minute. Here we are. I've started putting my applications on Microsoft Store. So if you go to Microsoft Store and search for Tim's Small Serial Pixel Editor, which is this one here, you can download or view in your store and just install it through you just click this button here, and what should happen is Microsoft Store should come up and you can install. It makes it so easy. That's all you have to do, and then you'll have this little application. So I'll just get rid of that, and this is the application. Now what we can do is this buffer here basically is, if you imagine each one of these bytes, so that byte, that byte, that byte, they're all these. If you imagine these LEDs as columns, okay, so these are, that column there has got 8 LEDs. That's 1 byte. Then the next column there. I tell you what, let me just get my hand, and then you know where I'm really pointing. There we go. So if you imagine you got 1, 2, 3, 4, 5, 6, 7, 8 LEDs. So 8 bits make up 1 byte. So that column there is 1 byte. Then you've got another column there, next byte, and another column byte there. So what you've got is actually you've got 8 that way. Each box square is an 8 by 8. So you got 8. 2 8 16, and then 2 16s are 32. Yep, so you got like there, you see I've got 32 bytes of information. So if you imagine each one of these is a column, what we can do is, like I say, when it booted up, it showed my display, and maybe you want to put your own name on, or hello, or something else as a test pattern. When it boots up, we can grab all this in my little application. So we know that it's 32 bytes is the width, so I'll put 32 in there. So what we're going to use is actually this is a little application for making bitmaps. You can draw and do things, and then you can sort of get the data, and it'll give you the 8 bits of data, or whatever, whether 16-bit or whatever. But it'll also read data as well. So we've got this this button down here called read data, and if you notice, we've got like an orange, an orange, an orange, an orange, and orange. This is like a color code to say these things will affect what we do when we press this read button here. So what I'm going to do is I'll just move my hand to the right when I click this clear data, and what we'll do is we'll grab this data, I'll copy that, and what I'll do is I'll paste it into here. And the main thing that you need to know is how long the array is, and we know that it's 32 bytes. We know it's 32 bytes, so what we've got is 32, because that's the width. So we've got like 1, 2, 3, 4, so on, 32 wide. It'll calculate the height from the 32. So all we do is we just go down, and we like I say, we're using vertical bytes, as I said, which is the orthodox way of doing things. So we're doing the vertical bytes, as I said there, and I want the output to be binary, because we can. So what I'm going to do is I'm going to put binary here, which is what matches this. This is binary. Bit size is 8-bit, and we'll just press the read, and there you go. We've actually read this, and that's what you saw when it started up. What I'll do is I'll just reboot this again. There we go, back in again. And there you go, you can see Tim hourglass and a thing. That's what you can see there. That's my test pattern. So if you want to change this so it boots up with something else, what you can do is use my little application here. You can zoom in and what have you. So what we could do is we just go transparent, and then we just rub all that out like that. You see, let's say my name, just rub my name out there like that. And so now you've just that as a test pattern, or you could just go black and just put your sort of own name in here. Something like that. Whatever. Anyway, you get my meaning. Whatever you're drawing there, and you just press this get data, and there we go. We've got this data here, and then you just copy all that, and then just go back to this and just paste it in, and just paste it in there, and then that is it. It's changed, and that will now be what we've got here. So you can see it'll come up with that when it starts up. So you don't have to stick with my name coming up all the time. You can change it here and put whatever you want. You can clear the whole lot, like so. Just clear the whole lot and put anything in there. There we go, and just put. You can put hello. Hang on, I can't keep it. There you go. You can stick that in there. Just click get data. Once you've got the data, copy it, and then just basically. In fact, actually, let's have. I wanted to have 1, 2, 3, 4 before, didn't I? So what you can do is you can make this output just 4 bytes per line. So if I put 4 there and then get data and then copy all, it will look something like what I had before, and just paste it in there, and there you are, you've got it again. So that will now change this here. So what I'm going to do is just put it back to what I had. Is that where I was? Let's go forward. Yeah, there. That's what I had. There we go. I can check that. So I got 2, 1. Yeah, that's the Tim there. Right. Okay. Well, I can check it. What we can do is I can just read that. So if I copy that, clear the data, paste it in, and then read the data. Yeah, that's how it was. Right. Okay. So yeah, this is a handy little application for making your own picture arrays and things. It does a lot more. I think I did a video somewhere. Anyways, so that's what you can do there with that. So basically, what we are continue with this now is we have our setup. This is just if this was to do whether I was going to do the debug. Basically, it says what it says there. So we set our pinouts. So there's our 3 pins that we need setting. Then we set them all low. We begin the Wi-Fi. This will be using whatever you put into the this bit here. Your name and password for your Wi-Fi connection begins, and then it displays the test logo, and then it also shows the IP address here. So this is just a little bit of code to well, let's just peek that. So basically all that does there, it just runs through the IP and it displays what it's displaying on there now, basically. There we go. And then we do a loop. It does a WebSocket loop. So the ESP 01 is not really doing anything. When I opened it up, you didn't see any clock chip or anything like that, or any other modules besides the ESP01, because all it does is collect web data. No, sorry. All it does, it collects data that you send it. So basically, the matrix will display anything you want. It'll display whatever you tell it to, and that's the way it works. Nothing actually the only thing that runs on this remote display is what you send it. So basically, all your calculations and everything, what to draw on here, basically, you tell it which LED to light up and which LED not to light up. That's what you do. That's all you tell the ESP to do, basically. And so basically, that's what this WebSocket loop is looking for. It's looking for that information. And once it sees the information, it will then run this bit of code here, and that's what it gets, and it sends that. It tells the ESP, this array that you have here, you'll be sending an array with some of these as ones and some of these as zeros, and that each one represents an LED on the matrix. And so that's all the ESP does. It lights up an LED or doesn't light up an LED. So all this WebSocket does is receive an array that you sent. So that is that bit there. Or it could actually send a command. I have put two commands in this, on and off. Then that turns off the power to the LEDs, on or off. So you can actually send it a command as well. So basically, it either gets the data, which is a binary data length of 32 bits, or it gets a text command. If it gets a text command, it sends a command here, so it sends that command, and all that does is send the command to the LED drivers. And then if it sends a matrix, which is, like I said, it's going to look like this, then it sends the matrix to the driver, basically. And that's all it does. It does nothing else. It doesn't work out the time. It doesn't work out what it's showing. It doesn't know. It doesn't do anything. All it does is display what you've actually said here. And basically, it's like drawing this here, and you send that picture as bits which are turned on or off. So whether it's a black one, the black ones will be filled in, and if it's a white one, the zeros won't be filled in. And that's all you actually send to this actual ESP. All the work is done on the actual web page. So that's it. This actual module that you just give power to just connects to your Wi-Fi and listens for data, and that's all it does. It does nothing else, and it just displays the array that you've sent it. All the hard work is not done on the chip. The reason being is that this chip, where are we? One of these. Where are we? Well, one of these chips, it doesn't have a lot of memory, and so you can't make it do a lot of work, basically. So we're making it doing as little work as possible. Yeah, it's all done by the web page. So let's have a look at the web page. The web page is pretty simple. I've got a few buttons, and I display a copy of this matrix. I think the best thing to do is to actually show the web page. But actually, what I want to do is all the code is done here on this script. Now, why have I got that like that? Oh, I'll just put a space there. Save that then. Yes, so it's all done by JavaScript. So basically, all the commands and everything are not actually done on the ESP01 chip. They're all done on your own computer or your phone or your tablet. All this code is run at super speed, and done on your own computer. None of this would have fitted on the ESP01. Yes, and I also have a styles file. This just sets the colours and things, if you know what web pages do. And I have my font, and this is the font for if you want to change the font. So let's pick an 8. So what you can do is you can use my thing to actually modify what an 8 looks like. We know that it's 1, 2, 3, 4, 5, 6 bytes long. So if we go here, put 6 in there. Oh, let's put 6 in there. Clear this, paste that, and then get read data. There we can see that's what our 8 looks like. Maybe you wanted to make oh, actually let's pick the 0. So if we look at the 0, copy that, we clear the data, paste that in, read that data. That's a 0. You may prefer a 0 that looks like that, and you can alter it. So then you just get data. Oh, right. This time we want it actually in actual hexadecimal. So what we do is we just change that to hexadecimal, and I want them 1, 2, 3, 4, 5. I want it 6 long. So I'll go 6. Get data, and there we go. We've got that. So we just copy that, and what we could do is we could just paste it in there. I'm not going to. I'm going to leave my 0 as it was. So yeah, so we can use my little image editor to edit your fonts as well, basically as well. Anything that uses bytes to show what you're actually doing. Like in this one, what I've done also is, because I'm only using 27 to save memory. Well, actually I didn't have to save memory. I could have put the full font in here, because this is all, like I said, this is all run from your own computer. So I could have actually put the degrees where it should normally be. But what I've done is I've altered this. This used to be character 126 is actually where are we? It looks like this. That's what character 126 should look like. But what I've done, so I only need to use the 27 character map, is I altered this. If I copy that and I clear that, paste in there, get data. I've used my degree character because the degree is in the extended character set, which is beyond 127 characters. So you'll see that come up later on. Save that. Right, yes, yeah. Right, yeah, I'll tell you what, I'll bring the web page. Let me just get hold of the oh, right, yes, the web page. Actually, so what I have done is I have a folder. I have a folder called web page. There we go. If we go there, look, there's my code. That's this code. That's the code. My credentials and the font. These 3 are required for the ESP01. Now my web page, if I was using an 8266, the bigger one, which has a lot of memory in, I could probably upload the web page to the ESP8266, but I am not. So basically we're running this web page. We need a copy of this folder on our computer, our PC that we're using. And in there, well, we've got our usually favourite icon. That's the icon that shows up in the top left on the tab, basically. Then we've got our index, which is our default name for our web page. We've got our script and our styles. Now, I have also made a bat file. What this bat file does, if you have Python installed on your computer, you can run this web page from a server. That's where web pages should always be run from, basically, really, is a server. But if I open up this page, what have I got open? Yeah, close that. If I just run this web page from my computer, so let's just open it, I'll double click on that. You can see that changed there, because my web page looks like this. This is what the web page looks like. Let's get it resized. There we go. So if we resize the web page, bring that down here. See, I've got a few buttons here. So I've got a button for chevrons, random LEDs, scroll, time, draw, power on, clear, and power off. So the first thing is, when you open up this web page from here, this is done from the user file. So you can see we've got a file there. There is no security with this, because we're just using it, opening it as a file. It'll work fine. I can click my chevrons. Let me just move that there. So I've clicked my chevrons. So whatever shows up on this web server will actually show up on the remote display. I can do random LEDs. So whatever's on here is actually on there. This is real time, basically. So this is real time transmitting to this, whatever it shows in this display. I can make them random LEDs scroll. I'll just press scroll. You can see it scrolling across. If you've got a fast eye, you can see that it's exactly the same. And we can click time, and so we can see that we've got time. In fact, actually there's a slight delay, isn't there? So it lights up here first and lights up there anyway. I can scroll that. Yeah, you saw the delay there. And clear that. Let's just put put random LEDs on. So random LEDs, and what we can do, if I power off, those random LEDs are still being sent to this. Only what we've done with the power off is we've turned the power off to the LEDs, not the actual thing itself. Because if I power on, it will come back to wherever it was. I suppose I could show it with time, but anyway, it's the thing. So it says 1421, and remember that there's no actual clock on this remote display. The clock here is actually from your own PC. So this is getting the clock from your own computer, or whatever you're running running this web page on. Is from your own computer. I forgot to say as well. Yeah. So actually, let me just reboot. So when you first power on, let me just repower that. I'll just unplug the USB and plug it back in again. So plug the USB back in again. Like I say, once it connects to your to your local network, it will display the IP address, because your IP address gets allocated by your home network router. And so you can see that it was 192.168.0.166, and that's what you need to type in here. Can you see that it's red now? It's not connected. But you type the address that it shows you in here, and you press connect, and then what it does, it will connect. This web page will connect. Once you've done this web page will then connect to the remote display. Now, as I said, you can display anything you want on here. So what we have is we have the draw button. So let's press the draw button. So we've stopped sending the clock, and you can see we've stopped sending there, and I can just now draw whatever I want on there. Let's clear. Oh, well, that's it. Let's just clear the screen and draw. So you can actually put anything you want on there. Basically, you want whatever you draw on this web page gets drawn on the display. So you can actually send anything you want, basically. And if you go to erase, and you can just erase them or draw. You see what I mean? Anyway, so whatever you draw here, so you can send your own messages if you want to draw and write your own messages. Clear. So you can go. I've got shaky hand. There we go. You can't read that. But to save you doing that, I have also got this down here, and what we can do is we can just type hello and send that, and that will actually send hello. If you want to scroll that, you can just click scroll, and it will scroll hello. Just click scroll again to stop. We can clear that. Like I say, put chevrons up there, and if I scroll them, it'll scroll whatever was on the screen at pretty much the time. Random LEDs, and we can scroll them as well. And time, of course, we've got the time. So also I've put on here now, because we're doing this from a file on our on PC. Like I said, there's no security. This is all done okay because we're telling it to on the our own PC. But if we want to use resources that are on the web page, on the World Wide Web sort of thing, like speech, or what's the temperature today, and things like that, and we want it to recognize our voice and send what we've said to the display, we can do that. But this requires some security protocols to communicate between the online services and our machine. And because we're not running it through a server, that none of these protocols are effective. So what I've got is this button here to speak, and I can just click speak and say hello. But what it's going to do is going to nag us here. This file wants to use your microphone, so we've got to allow that. Click that twice, and I say hello, and then it will work. Basically, what I was saying, and I say hello. It will work, but the thing is, we're going to get that nagging pop-up every time we click this button. So if I click the button again, we get the nagging button again. So allow, and now we get it again. But it works. Now the thing is, what we can do is, if we run it through a server, and I'm assuming most people that do this type of project have Python installed on their machine. If you've got Python installed on your computer, then you can use Python to run this web page in a server. So if we run it through a server, then all those security protocols are going to be implemented because the web page is run from a server. So what I'm going to do is close this, and I've written a bat file to make it easier. So basically, well, I'll tell you what, let's edit this. I'll show you what's inside. There's nothing malevolent. There's no malice inside this bat file. It's not going to do things to your computer. Basically, we've got echo off, and we're telling it to start in Python server on port 8080, and we're going to start a server on our local host. That's all we're going to do with this. but because we're running it inside this, I pressed the wrong button there, run thing there, this is what I wanted. Because we're running this bat file in this folder where all our web pages are, what it'll do is it'll treat this folder as the web server resources, and it will run the index, the default index web page. So basically what we do, if we double click this, now you'll see that there'll be two terminals open, and then one will close. The first terminal is this bat file running. The second terminal is the Python server running. So that terminal will stay open because it's the web, the Python server. So I'll just double click this. You see that there was two things opened, but the first one was the actual bat file running, and this second one is this Python server running on port 8080, and we're looking at this index page. It's opened it up on my other screen, so it's the same page, but let me just resize it. Let me hands it where. There we go. Just resize it. So now we're running it through a Python server. We can see that this is now run off a local host. It's running off our computer, but it's this server, this server that is actually running the web page. So now when we press speak, you should only get the nagging dialog once, but because I've run this already, I may not get it. So if I go speak, hello world, we see that we're not actually getting the nagging thing anymore, because it's, I've got that covering the output there. So the idea is that this little remote display that I've got, you can put it in your kid's bedroom, and then you could open this up on your phone or whatever, on your computer or something, and you can say, right, come, it's breakfast, get up, breakfast, or something, and you can send a message if they're watching. Make sure this is stuck on front of their computer screen. They can see it light up. Anyways, or I can put it in the kitchen, and I can say to Sue, make me a cup of tea. So basically I'll just press speak. Sue, can you make me a cup of tea, please? Now you see that's just to run the once, but just in case you didn't see it, or whoever didn't see it, wherever you've placed the remote matrix display, you can see that it's actually also placed what I said in this text box here. And what you can do is you can just scroll, and it'll just keep repeating like this. That reminds me, my cup of tea is going cold. Well, when that ends, I'm just going to pause a minute while I drink my tea before it does go cold. Oh, it's not going to end because I've got scroll on. Anyway, right, just 1 minute while I drink my tea. There we go. Yes, so the one good thing about this is this device. Once you've made it, it never needs to be changed. You don't have to change the code or anything on there, because all the code is actually on your PC. All the code is actually in this folder. This is all the code here. We've got the index, we've got the array, the matrix if we want to change it. So whatever we change here is instant. We just refresh this page and it's instant. And basically it's this script one here, this file, which is here. This is the script file. So whatever you change, or you can add it and make it do more functions. This is just the start, is this. I mean, these buttons here, you could add more buttons here. To add buttons, you just alter the index. Where's the index? Here. So we've got buttons here. All the code and everything is actually done in these files that are not actually on the microcontroller. All the things it does is not here. One thing that I haven't shown and put a button for is some commands like maybe I want to know what the weather is. So so we've got chevrons, we've got random, we've got time. So if you say one of these key words like speak, so I'll just do it. Time. It'll do the time button if I say chevrons. And what I'll do is I'll try the random. And it does the random. Speak again. Scroll. Oh, I thought I hadn't done that one for a minute then. Yeah. So what we can do is I'll clear that. I'll click the button or speak the time. And the other thing is what I haven't shown here. I've done another one because this web page is on your machine and your machine is connected to the internet. You can also use resources like the weather. Maybe you want to know what the weather is in your area. So if I just go weather, oh crap, I changed that string, didn't I? Right, yeah, right. So we've got the weather going there, scrolling across there. So we've got, it's 13 squiggle degrees C. Can you see I've changed? Where did I change that? I must have pasted it in, did I? And we got 9 p.m. 9 miles per hour. That's the wind. So we've got 13 degrees C. Can you see that the degrees is wrong? Then we've got 0%. Well, that's supposed to be the humidity. And then we've got now 9 miles per hour, which is supposed to be the wind speed in this area. So, right. What I'm going to do is I'm going to put that, where are we? My fonts. Let's have a look. Right, that's supposed to be degrees. I must have changed it. Right, so I'll just put that up there so we can see it's still running. Okay. Right, what I've got is, this should be degrees. Well, it is degrees. Why isn't that? Alright, let me just think about this. Oh, unless that's running in... Oh, I know why. Right, okay. Right, so when you run a web browser, it doesn't always download all the files from the internet. It will download maybe the front page, the web page, and if it thinks the web page hasn't changed, it will use what it's got on your computer already. So I think what this is looking at is the file that's already on my computer. It's in the cache. But what I need to do is to refresh this with Control F5, because what I want it to do is I want it to update this font. You see, because this file is actually a separate file in here. So we've opened this file, but what it will do to save time downloading all the information and everything off the internet, if it was on a server on the internet, that was. It won't download this font file. It will use what it used last time, and I've already had this open before doing this video. So it will be using the font file that I was using prior to changing this value here. So now that I've changed that value there, instead of just pressing refresh, because all refresh does is refresh this part of the web page. It does not refresh the other pages because it uses what's in the cache, really. So what you need to do is to press Control F5. If I press Control F5 and I refresh the page, what it should have done now is refreshed itself with this new updated font file. This is where it tells me I'm a liar, so let's just check that. Weather. There we go. Because it's now refreshed itself with the updated font file, it now puts the correct the correct font file, and I've now got me 13 degrees C. That might have been of some use to somebody. The reason why it's doing naught is because what I've done is, let me just show you the code. So in the script we have we can put commands. These are all the commands that it recognises. So like I say, I've got chevrons, random, scroll, time. Oh, I've even got clear, power on, power off, and weather. So when it recognises a word that we've set, one of these words here, weather, power off, power on, I can test power on, power off. Oh, it's decided to do it. Right. Power on. There we go. So, yes. So that I've done all the buttons there. So the weather one will do this function, which is what I have here. This is my weather function. And what we're doing is we are going onto the internet. This is this bit here. So what I'm doing is, you know, when you if you open up a browser, well, let's do it here. Right, we open a browser and we go IP, and then we go say this one here. What's my IP address? And it tells you your IP address. All right, I'm not going to. Oh, right, it's already showing you. Anyways, but you know what I mean, IP address. So basically, that's what this bit's doing. This bit is fetching from this site here, IP info ID Johnson, and it'll come back with your IP address, and it'll come up with your latitude and longitude. So that's where you are in the world. So what it does, it looks first to see where you are in the world by using your IP address, because your IP address are allocated by companies to companies who allocate it to your subscription companies, and so there's a record of where your IP is, basically, for your connection to the internet. and so it uses that one there to into the next bit. So when we go to the a servo, I keep saying servo, a server, right? So there's an open meta meteorological site. This I've used a free one here, but you could change this for one that you've signed up to and get more actual information off it. But the one I've used, it will return. What will it return? Well, using longitudes. It will the latitude and longitudes. It will get the current weather for the hour. It will get also it will get the humidity if you force it to, but it doesn't always give you the humidity, and I don't know why, but sometimes the humidity, so we've got the 13 degrees C, alright, but we'll end up with a 0 degrees. It doesn't always get the humidity done this side. It doesn't always give you it, basically. But it'll give you the weather and it'll give you the wind speed, alright. So that might be a 0, so I'm clueless, but it says the wind here is 9 miles per hour. Yeah, so what I'm saying is you can add stuff and get it to do stuff on the internet. I mean, basically this is the whole concept of what was it? Yeah, IoT, Internet of Things. Basically, normally you would sign up to a server, a cloud in the server fields, some cloud, you pay money for that cloud, you connect, and that cloud server will then get all this information for you and bring it back to whatever you want, the information you ask it for. But this is all done free, basically, and that's why I've used this one here, because this is a free one. Yes, so and basically I need to change that I'll just put, because I originally had it looping through some things. I think I'll just put it as show weather. I think I changed that. I don't like the word in there because it's not doing what I say it is. Yeah, show weather, that's it. That function now is actually just showing the weather. That bit there is actually just doing this bit. It does a bit in the web page, and the web page then sends a copy of what this web page is to the ESP01. I think I've covered everything there, I think. Okay. Hopefully you found it interesting, actually. Let me just... Why isn't it going across to here? This is frozen. My thing's frozen. Give me a minute. So set that back up again. This is my... has battery run out? Or has it got hot? Let me just see if I can... the whole thing's crashed. Right, give me a minute. My camera's crashed. There we go. Camera's working again now. Yes. So, what is more is there to say? Really, I don't know. Basically, all I'm doing is just showing you how everything can be actually done on your own PC, and you can still get it to show on... I messed that up, haven't I? Yeah, there we go. Show up on something and send it on, basically, the easy way. Because if we look at all the... what have we got there? Properties. We've got 69 kilobytes. So, and I think there's only... Well, actually, size on disk is 80 kilobytes. And so if we add 80 kilobytes to this one, 88, maybe I could have fitted it on there. Oh no, there's these two as well. properties. So what we got? 96 kilobytes. So we're nearly getting there to a megabyte. I suppose I could have put all this actually on the chip, because the chip actually has 1 megabit of memory. Oh no, this is this is only 80 kilobytes. 1,000 bytes, and the chip and the memory is just 1 megabits, which is I think it's bits or bytes. I don't know if it's bytes or bits. Anyway, I don't think it'll all fit on the chip. So I'm going to end it there. I'm rambling, and I bet it's gone on for ages. How long has it gone on for this video? Oh god, 1 hour 10 minutes. Yeah, so I'm going to stop it there. I hope you found it some interest. I haven't even shown you. Right, hang about. I wanted to show you this as well. I wanted to show you it in there. Yeah, so this is my box. So if we just get rid of the case. Yeah, I wanted to show you that I've just used one of these surface mount 3.3 voltage linear voltage regulator. I've used a resistor for the enable, so that goes from the 3.3 volts to the enable pin. So I've just used a bit of perf board that size. So what we got: 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 by 10 bit of perf board. And what I've done is, I've stuck a header going that way. It needs to be one of these flat ones. So, hang on, sorry, it's this one here. So the header that's in this piece, it needs to be one of these flat ones for it to fit inside my box, basically. Not one of the other ones that sort of are raised up. You know, this bit is like vertical here. If you make that, that's going to go. All this lot is going to get pushed down, and it's going to be too close to the piece of wood at the front. So, and I've used one of these types of breakout boards for the thing, and I've just lined it up with them pins. So these holes line up with 1, 2, 3, 4, 5 in, and they line up that way, and that makes the length of this correct to fit inside my box. And that's it. Now the wiring I've done in PDF. Well, I did a fritzing. Yeah, have I got the fritzing? 1 minute, let me find it. Yeah, I've done a fritzing, so it shows the perf board there, the size of the perf board. I've shown it as one of these big linear regulators, but I've used a small one. The only difference is you've just got to watch the pin out. Now I've left the rat's nest on here because come on, zoom in. The zoom on this is shit. I've left it as a rat's nest because I think I've just the best thing to work out, because this thing here, this header block here is actually a horizontal one, and it fits underneath here, about here somewhere. Hang on, where's my hand? Yeah, this header block is actually a horizontal one, and it fits underneath here somewhere. So the best way to sort the wiring out is to look at the schematic. I've done a schematic, so basically we've got a voltage regulator. But here I have got, see, it says pin 1, pin 2, pin 3. What I've used is a surface mount one, so my pins are not the same numbers. I think it goes pin 2's input, pin 3's out, and pin 1 is ground, I think. I don't know. But the pin out on the surface mount and the through hole version are different. But basically, if you just follow the input, look up the datasheet and get the input, the ground and the output, make sure it's right. The USB, like I say, it's just supplying 5 volts. It just has 5 volts on this rail. Then after the voltage regulator, we have 3 volts. Just make sure that you've got the right voltage on the pins. We've got our enable pin with this resistor going to VCC, and then we've got the TX pin for the cable select. And we've got the clock on O, and we've got the data in on 2, and so on. Anyway, it's best to follow this, but what I did was I did do the breadboard to sort of give you an idea. This breadboard here is different to the one that I've used. Sorry, this breakout board is different to the one I've used. So hopefully you can get that from this picture, basically, which is this is how I've actually fitted it in, so it all works basically and fit inside my box. This is the type. You're looking for one that looks like this. That's the reason why, if we put the box on the case, that's why this case has got the hole cut like this. It's got a long slot so that the PCB actually comes through it a bit. But if we remove this top bit, back, yeah, remove the back and look inside, you can see that although this actually sits through, the perf board doesn't. The perf board actually sits against the piece of wood, so it doesn't fall out. But yet this PCB will actually go through the piece of wood. This is because really this USB socket should have been extended beyond the PCB so you can get it flush with the outside of the piece of wood, if you get my meaning, but they haven't done that, and I think that's why these I got these so cheap, because they're pretty much shit, really. They're rubbish. So but if you do something like that, then you can okay, I mean, you don't have to do this. I'm rabbiting again. You can just put a round barrel jack just to supply 5 volts, really, but only 5 volts in. That's all you need to do. Yeah, so there's my thing still going with the weather. Well, okay, so I hope you like that. I think I've finished it now. Anyway, I'll tell you what, I'll pause and have a good think. Okay, I've had a good think. Anyway. Okay, I've had a good think. Hope you enjoyed this video. Now, why isn't it showing up? What have I done here? I wonder if it's because of the weather. Hang on, let's just clear. Time's there. Right. Something I might need to look at there. I should have just checked. What I should do is really get another one of these, make it eight blocks long. Thank you guys for watching. See you in the next one.